Hi, and welcome back to Clarkenomics. In this video, we're going to examine what a shortage looks like in a perfectly competitive market. So here goes some cool effects, and there's our graph. So same graph as some of the previous videos I've done. We've got the market for pizza. It's a perfectly competitive market. Price is on the y-axis. Quantity is on the x-axis. And we've got a supply schedule in this column, and we've got a demand schedule in this column. So in previous videos, we talked about the market equilibrium price being $17.50. X marks the spot. Right there is where we'll find 17.50. But again, we're going to imagine a situation of disequilibrium. In a previous video, we talked about what a surplus looks like. In this video, I'm going to talk about what a shortage looks like. So first, let's imagine that the price of pizza was $5. So I've got a green line going across here and a blue circle in my schedule. So at a price of $5, what would the quantity demanded be? Well, the quantity demanded would be pretty high, right? $5 per pizza is a very low price. So the quantity demanded is going to be 6,000 pizzas at that low, low price. Consumers are going to want a lot of pizza if it's only $5. Unfortunately, if the price is only $5, the quantity supplied, where this line hits our supply curve, is only going to be 1,000. So here you can see in this row of the table, at a price of 5, the quantity of pizza supplied is only going to be 1,000, but the quantity demanded is going to be 6,000. In other words, this is going to leave us with something called a shortage. And a shortage in this case is going to be 5,000 pizzas. Quantity demanded exceeds quantity supplied by 5,000 pizzas. So this is where we would find a surplus, right? The horizontal distance between our quantities. We're measuring the shortage in pizzas here, not in dollars or anything like that, but in, the quantity of whatever the thing is. So if the price were, let's say, a little higher, let's say $10 per pizza, the quantity demanded would still be pretty high. Quantity demanded would still be 5,000 pizzas, but the quantity supplied would only be 2,000 pizzas. So in this case, we're still going to have a shortage. The shortage isn't as big as it was when the price was $5. This time the shortage is only 3,000 pizzas. So it's better, but we're still not at the equilibrium. If the price of a pizza were $15, we're getting closer, right? Because if the price of a pizza is $15, the quantity demanded, which we can see right here, would be 4,000, and the quantity supplied would be 3,000. And while we would have a small shortage this time, a shortage of only 1,000 pizzas, we would still have a shortage. So there's only one price where this shortage would cease to exist. If the price were $16 or $17, you'd still have a shortage, a small one, but it would still be there. But at a price of $17.50, which we're going to put right there, $17.50, there's our table, where it intersects, X marks the spot. That is the only single price in this market where quantity demanded is 3,500 and quantity supplied is also 3,500. In other words, QD and QS are equal to each other. That's our magic point right there. That's our market equilibrium. Because, boom, right there. You've got 3,500 for quantity supplied and 3,500 for quantity demanded. In other words, there would be a shortage of 0 pizzas. In other words, not a shortage at all. We would be at our market equilibrium quantity. So that's how a shortage works. It's very similar to a surplus, but just like a surplus, these are situations of disequilibrium. Disequilibrium is where the price is not the market equilibrium price, and there is a differential between quantity demanded and quantity supplied. So I hope that helps clear that up. Thanks for watching.